Alright, this is the week 2 summary for Physics 112 with David Weber. When we first got back into class this week on Tuesday, we got a Nervous About Nerves worksheet, which had a couple questions on it, and we got the whiteboards out again. And as a group, we went over what we best thought those answers would be. This is a picture of the whiteboard with what we thought the answers to those questions were. And then the next sheet on the other side, we decided to use the battery pack and some lights to best represent our the limbs and vital organs, and the light bulbs to represent those. And we had some copper wires that represented spinal cords, and we had to make a circuit that represented the human body. And this is it. You can see kind of here would be the head and the arms and the legs. We tried to kind of base it off the same layout. And once we got that lit up correctly, we put that on top of the drawing of the human. And then Professor Weber came over and cut the spinal cords to represent a paraplegic and a quadriplegic. The video I took didn't come out very well for some reason, but once he cut the copper wire here, the bottom two wires, or the lights, went out. And it was kind of funny in our video, the wire got cut right here. I don't know if you can see the mouse, and only one of the arms went out, and we started kind of freaking out thinking that we wired it wrong, but this black wire was tucked under there. We just didn't cut it high enough. But so that was crisis averted right there. And then we also had another sheet. It was qualitative reasoning tasks, and we put the circuit that was given on the paper and we wrote it out so we could, like you see right here, wipe off what circuits were broken, or if the wire was cut at certain locations. We could guesstimate and work through as a group what would happen to the remaining lights, if they would stay on, dim, or nothing would happen at all. And then over here, this was some example of that, where you can see the wire, the battery is going to the light, and then we have two wires coming off of it. So it's going to, each light following that is going to get half of the power. So you can't see it in here, but if you looked really closely, both the lights would be slightly on. And then we took the light bulb out here, and you can see both lights are equally lit again. And then we started, this was Thursday's class, we started doing some more multimeter stuff, taking resistances, voltages, and currents. And resistance, there can be no power to the circuit, so this is without it hooked up. And then I don't think this is actually a picture of the resistance, but we measured with the light bulb out, we had 2.75 of resistance, and then with it in, it was higher. The voltage with the bulb out was 1.994, and then with the bulb in was 3.177. I think that's, that would be the current. And then the current of the bulb 1 was 0.314, bulb 4 was 0.155, and bulb 5 was 0.159. And if you look at this, you can see that's bulb 1, and this would be 4 and 5. So that would make sense. They should be about half the current, because if they're drawing off the same bulb, it's not going to get the same amount. So these are just some pictures of our readings. And then we also brought out magnets, and we had a couple questions. And this was a statement Professor Weber said: the source of all magnetism is moving charge. So we went into kind of an in-depth conversation of magnetism, and there was 3 questions. What is the moving charge that causes Earth's magnetic field? What is the charge moving in a permanent magnet? And then we also went over Lenz's law and power, and we found that power in watts is equal to the current times the voltage. And then, let's see here. Oh, then we started to kind of make a source of a motor, in a sense. We wrapped a copper wire around a battery to make the like a little sphere, and then we put a battery in with 2 little metal prongs sticking out. Let me pull up a video. And here's this all put together, and you can see that it is spinning the wire by itself. And then on to some Arduino kits after I got home later that day. This was the first one. Press the bulb. I think this was I believe it was called the rocket sequence. So you press the bulb down and these two red lights would flash, or the button, sorry, and then the green one would stay on as a constant. Here's the levometer, and I think I have a video of that. Right here you have it's a sensor and it can tell different temperatures. So in the programming, different temperatures will result in different amounts of bulbs being lit at different times. Alright, sorry this is upside down, but you can see my finger is going to be the source of the heat in this situation. The second bulb comes on fairly fast, and the third one, I'm assuming it's because the temperature was right up there with my hands, so it took a little while to heat it up, but you can see it came on eventually and then shut off. And then the fourth project, the color mixing, this is the coolest project that we've done with Arduino yet. You can see this is the start of it. We have some, let's see here, we have some sensors and some more resistors, and this was before I put some more of the wires in. There's it all lit up, and then I will pull up a video of what that does. And you can see if you color up the sensor, it'll change the bulb, because it's got a 3-color LED in there, which was pretty cool. I played with that for a good 5 or 10 minutes just trying to change different colors. And that's about the end of week 2 in Physics 112. Looking forward to the rest of the Arduino projects. I was kind of looking forward in the book, and they do get a little harder, but the results and the payoff is going to be a little more satisfying. So I'm looking forward to that.